Let's now find the inverse of this given matrix A. So the first step in determining the inverse of this matrix is to find the determinant of this matrix. So this is written as determinant A. So let's find the determinant A. This equals, we expand this matrix along the first row, and when we do that, we have 1 multiplied with, we have to leave out the first row and first column. When we do that, we get this determinant, that is 0, minus 1, minus 2, minus 3. Then we put minus. We then have this negative 1. So it is negative of negative 1 multiplied with the determinant by leaving the corresponding row and corresponding column. So we basically leave the first row and second column. When we do that, we get 1, negative 1, and 6, minus 3. Plus the last element is 0 times of 1, 0, and 6, minus 2. We can simplify this. So therefore, determinant of A equals, this is 1 times of negative 3 times of 0 is 0, and this is negative of negative 2, negative 1. So it's basically becomes negative of negative 2 times of negative 1, and this becomes negative of negative 1 is positive 1, so it becomes positive 1. And when we find this determinant, we get negative 3 minus of 6 times of negative 1, which is negative 6. And then plus 0 times of, we will have something. So we can just put it as it is, because 0 times of any number is going to be 0. So this simplifies to negative 2, negative 1 is positive 2. And this becomes negative of positive 2 is negative 2. Plus this one is 1 times of negative 3, positive 6. So we have negative 2. Negative 3 plus positive 6 is positive 3. So this reduces to negative 2 plus 3 is positive 1. So we found the value of determinant A equals positive 1. The next step to finding the inverse of this matrix A is to find the adjoint of this matrix. So to find the adjoint of matrix A, we will first to find the cofactor matrix of A. So the way that we do this is, let's write down this cofactor equals, we start by the first row and leave out the first column. When we do that, we get 0, negative 1, and negative 2, negative 3. So basically we have to find this cofactor matrix. So I'm going to write down in matrix format. So then we move to the next element, negative 1, which means we have to leave out that row as plus that corresponding column. And when we do that, we will have 1, negative 1, and 6, minus 3. We will put the sign later on once we construct this matrix. So, and then we have to look into the first row and third column. When we leave that corresponding row and column, we will get this matrix or this determinant. This is 1, 0, 6, minus 2. So likewise, we can construct this matrix. So let's do that. And here we will have negative 1, 0, negative 2, negative 3. And then when we leave the second row and second column, we will have 1, 0, 6, negative 3. Maybe I copy the matrix A over here. So let me copy the matrix A over here. This is 1, minus 1, 0, and 1, 0, negative 1, 6, negative 2, and negative 3. This is our matrix A. Now we have to write down this element. That is, we have to leave this row, that is second row and third column. When we do that, we will be left with this determinant, that is 1, negative 1, and 6, negative 2. And let's move on to writing the third row element. So here we have to leave this third row and first column. When we do that, we get negative 1, 0, and 0, negative 1. And to write down this element, we have to leave the third row and second column. And when we do that, we get 1, 0, 1, negative 1. And finally, to write the last element, we have to leave the third row and third elements. And when we do that, we get 1, negative 1, and 1, 0. So basically, this is a cofactor matrix. We have to put the sign. That is, we will have positive, positive, not here, positive here, as well as positive, positive. Rest of them are negative. That is, this is negative, 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 and negative. Now let's evaluate this determinants inside this matrix. So let's do that. So here we have this cofactor matrix, and let's simplify this, or we evaluate all the determinants inside this matrix. So when we do that, we get the first element is negative 2, and the second element will be negative 3, and the third element will be negative t. Basically, we just have to determine all the determinants. So each of the determinants can be utilized or found as like this. Suppose if we consider this determinant, that is the first determinant, we have to find the product of the diagonals. That is 0 times of negative 3 is 0, and then we put minus. Then negative times of negative 1 is positive 2. So basically this becomes negative 2. So that is why I have written negative 2 over here. So likewise, we have to find each of the determinants. When we do that, we get the next row elements as negative 3, negative 3, and negative 4. And finally, the last row element will be 1, 1, and 1. So this is basically the cofactor matrix. Now, the adjoint of this matrix, we have to find the adjoint of matrix A. So for this, what we do is we keep the diagonal elements as it is and reflect the other elements over this diagonal. So when we do that, I'm going to write down this diagonal elements as it is. That is negative 3, negative 3, positive 1. And then we have to reflect this negative 3 with this negative 3 element. That is, these two interchange the positions. So since these two are negative 3, I write down negative 3, and we'll also have to interchange the other elements. Negative 2 will be interchanged with 1. So here we will have negative 2, and here we will have a positive 1. And finally, we will also have to reflect this negative 4 along this diagonal. So this element will become negative 4, and this element will become positive 1. So this is the adjoint of matrix A. Now let's replace the formula to find the A inverse. A inverse equals 1 by determinant A times of adjoint of matrix A. Adjoint of matrix A. We already found that the determinant of A is 1. So therefore this becomes 1 over 1, which is 1, and 1 times of adjoint of matrix A. So it's basically, this is the determinant of this. This is the inverse of matrix A. So we write down A inverse equals negative 3, negative 2, negative 3, positive 1, and then negative 3, negative 3, positive 1, and negative 2, negative 4, and positive 1. So this is the inverse of matrix A.